The most important task for a data analyst or a data scientist is the data visualization. Data visualization helps business stakeholder analyze the reports regarding sales, profit, etc. As we know, a picture speaks 1,000 words. So a large amount of complicated data can provide many opportunities, as intuitively we humans can grasp picture very easily. Visualizing data helps to find many hidden errors easily, and it helps to predict the future sales, etc. Some of the examples are box plot, time series is the bar plot, heat map plot, and scatter plot. So these all plots we are going to study in our upcoming session, and hope to see you there. Welcome to the world of visualization. We all know that a picture is worth 1,000 words. A message which cannot be conveyed from the data, visuals can convey the same message in a very powerful and effective way. So let us take an example here. So here I am having a 3 scatter plot of sales data versus the mode of marketing. Like the first plot, the YouTube ad versus sales. Second is the Google ads versus sales. And third, FB ads versus sales. Now from this, it is very clear that the YouTube ad is the most effective way of selling a smart. But if you might have seen the same data on an Excel, then it would have been a very difficult to come to the conclusion. Now, in any visualization, pre-attentive attribute is of utmost importance. So these are the visual property that we notice without using a conscious effort to do so. Pre-attentive processes take place within 200 milliseconds after exposure to a visual stimulus. And some of the factors that make up to the pre-attentive attributes are color, which is intensity or hue, form, that whether it's a line length, width, size, shape, etc., and the spatial positioning, like 2D positions, and the movement. So that is why in our session of plotting the graph, we have to pay attention on these 3 factors, which is color, form, and spatial positioning. Attentive attributes, on the other hand, are very difficult to spot. For example, if we want to find out the how many times number 3 appears in a series of number from 1 to 99, then it's very difficult to spot. Let us now go through some of the types of chart and when to use them. The first is the bar chart. Now, bar chart will be used when you want to plot a categorical variable against some numerical value. So in this example, on the x-axis, I am having a group of age. So 1, 2, 3, 4. So 1 represent the age from 0 to 10, 2 is from 10 to 20, 3 is from 20 to 30, and so on. And on the y-axis, I am having a response rate for each of the age category. So this is where bar chart can be used. Now a histogram are used when we want to plot a continuous variable and see how it is distributed across the data set. So in this example, I am having a miles per gallon on the x-axis. So it is a continuous variable having the values like 10, 11, 12, 13, 15, 21, 22, etc. And on the y-axis, I am having a frequency, the count of cars. Now pie chart best summarizes the share of different components in an aggregate whole. If you want to analyze the proportion between among the different categories, the pie chart is used. But sometimes pie chart may create some confusion also, because it is very difficult to analyze if the values of the categorical variables are too close. For example, in this case, diverse primary is 9% and single primary is 7%. If we did not have this value, then it would have been very difficult to differentiate between the purple and the blue color and find out that which one have a more area. So this is one of the limitation of the pie chart. Now line chart, when you want to know the general trend over a period of time or a trend against a factor, the line chart is used. And you can see that over the time, the unemployment rate has been increasing. Now scatter plots summarizes the variation of the 2 points or 2 parameters. So in this example, I have a price on the y-axis and a diamond caret on the x-axis. So we can infer from this plot that as the price is increasing, the caret value is also increasing. Now, box plot is most suitable to represent the quartile, percentile, and outlier values. So here I'm having a 3 categories versus sales like office supply, technology, product category, and furniture. From this, we can observe that the sales of technology and furniture is almost equivalent, but there are some outliers. If you see the bold points, it represents actually the outliers values. So let us now start doing the visualization and let us plot some beautiful graphs. Let us now start with some basic plot in Python. So for the matplotlib, the most common library in Python to create the plots. So let us first import our tool library NumPy as NP, Pandas as PD, and then here also we are uploading a new library matplotlib.py plot as PLT. Okay, once done. So here I am creating a two variables x and y, which are the list of number. My x is 1, 2, 3, 4 and y is 10, 20. So I'm creating a list. So here I have the output. Now let us plot using PLT, which is a matplotlib. So here we have this straight line plot. Now on the x-axis we have 1, 2, 3, 4, 5, and on the y-axis they are 10, 20, 30, 40, 50. So this is a straight line plot. Let us plot the another one. So here I'm creating a NumPy array of 10 numbers, which is randomly picked 10 numbers. If you remember, my variable x is having 10 numbers ranging between 1 to 25, and variable y is having also 10 number ranging between 10 to 1000. So this is my output. So I'm going to plot it here. So this is also a straight line. Now if you see here, the plot.show will show you the output. If you don't want to put this plot.show, so it will give the output as this one. So to remove this one, you have to put it plot.show. Now this is really not very readable. Our layman will not know that what is x and what is y. So we have to put some titles here. To put the titles, we can make the use of x label, which will give the name of the x axis. Y label, give the name of the y axis. So input x numbers, and you can put y numbers, and then you can also name the title of the plot. So let us see my output now. So here is my output. You can see x numbers here, y numbers, and my first plot is the title of the plot. Now instead of the line, you can also replace with some characters. So to replace character, we can use the third argument. So here I'm replacing this one with star, and then I'm getting another plot where I'm replacing with y star. So basically y stands for yellow color. So let us see the output here. So here we have star, and if you see it's a yellow stars. You can do some further research to find out the color coding for the plots. So now we can also draw on a single plot multiple plots. So we can make the use of x and y is my two variable, b is the color of the plot, which is blue, then x and y. So here my y is a square of the number, and here my plot will be yellow with this symbol, and then my third plot is x and cube of the y, and it will be denoted by star. So you can see on a single plot you can draw 3 lines. So here we have 3 lines. Now sometimes you need to create a multiple plots on a single page. Now to do that, we can make the use of subplot. Here what I am going to do, here I am going to plot 3 diagram, 3 figures here. You see my output. So here what I have done, if you see the numbering, so here my first number represents the number of rows, second number, which is 3, it represents the number of columns, and 1 is the value, it's a position of the first plot. Likewise, if you see the second plot here, 1 and 3 is the matrix of the plot, and 2 is the second plot. 2 is the location of the second plot. Likewise, 1 and 3 the matrix of the plot, and 3 is the location of the plot. So it's like this, 1 and 3. So if you want to have a 4 plot, you can put two rows and 2 columns like that. So the output is here. So first plot example, second and third example. If you see my first plot, I have put my title as first plot example here, and I'm plotting x and y. Likewise, I'm plotting the second, and my plot subplot is 132. Likewise, third plot is 133. So let us now create 4 plots here. So here if you see my matrix here in subplot 2 to 1. Remember 2 to 1 is 2 by 2 matrix. 2 by 2. And 1 represents the location of the first plot. First plot example, then second I am plotting second plot which is the square of the number. Third plot I am plotting which is cube of the number. And fourth plot I am plotting which is y power 4. So here is my output. First plot, second sample, third sample and fourth sample. So you can plot on the 4 rows. Remember your plot show should be the last one. Should be at the last. In the next session, we will do some advanced plotting. We'll make the use of box plot, bar chart, then histogram chart, etc. Now we are going to upload the marketing data set. So I have 5 data frame which I'm uploading. Let us see the market fact data. Okay. So now under the market fact data, I have sales, discount, order quantity, profit. These are the numerical value. Now to plot the numerical value, the best way is the box plot. Now the box plot actually tells the range of the value, it tells the median, it mean, and 25th percentile, 75th percentile. Obviously this you can change it. So let me first plot the box plot. Okay, now here I have a box plot. So on the y-axis you can see the range of the number of the order quantity, and the orange line indicate the median of the column order quantity. So basically this indicates that the values under the order quantity are fairly reasonable and there is not much variation in the order quantity. Let me plot the another one of the sales data. Okay, the output is really not readable here. So it's because of the sales data are having wide variation. If I describe the sales data here, if you see the difference between mean and the median is very, very high. Likewise, the difference between 25th and 75th percentile are also very high. Now, to make the data reasonable, we can make the use of the log function. So what the log does, it actually it brings the value to a reasonable range. So it's quite readable without any loss of information. So here what I have done, now here I'm going to plot 2 box plot of same column, sales data and sales data. The only difference is that I'm going to scale the sales value by using log function. Now here if you see my first sample is not readable and my second sample it is now readable. Now in the box plot there are few things which you need to understand. First thing is that there are some points which are out of this line, which are above this line. So these are called as an outlier. It means that this line shows 25th percentile and this line shows 75th percentile. These outliers are very, very high value. So under the sales column, there are some data which are very high value of 10,000 or 20,000. But the most of the data are within the 25th to 75th percentage. So let us now do another plotting. So we will plot the histogram. So basically histogram tells the quantity of the value in a data frame. So from this output we can infer that, first of all let us understand the meaning. This shows the sales value and this shows the frequency of the sales value. If you see, the lower the sale, the higher is the record count, and the higher the sale, the lower is the record count. We can also plot two variables together. So this is called a scatter plot. So it shows the sales versus profit. Sales is on x-axis and profit is on the y-axis. And if you see the distribution of the plot here, there is one outlier. But from this plot, you can really understand that the higher the sale, the higher the profit. But then, if you see, there are some values where the sales is higher, but the profit is negative. So this tells two stories. First of all, most of the data are having higher sales and higher profit, but there are few data where the sales is higher, but the profit is low. So such a situation we need to avoid. So in the next session, we are going to learn more about the advanced plotting like Seaborn, which is a library beginner Python, and it will be used for beautification of the plot. In this session, we are going to use Seaborn library, which was built over matplotlib. The difference between Seaborn and matplotlib is basically a base plot library, but Seaborn gives the beautification to your plots. So let us start with, we are going to import Seaborn library as SNS, this is a standard, and then we have to set style to a white grid. Now other styles are dark green, dark, white and fixed. So about these styles you can study further on the websites. So basically white grid style we have chosen because it is good for the large sets of data. So let me import and execute. So for our study we are going to again make the use of market fact data. So I'm re-importing and executing. So these are the top 5 rows. So now I'm going to plot a histogram and density plot. So I'm going to tell the shipping cost as one of the column. So let me see the output. Okay, now you see the output here. Now on the x-axis you can see the shipping cost, and on the y-axis you can see the. So it means that if the shipping cost is lower, you have more number of records, and if the shipping cost is higher, you have less number of records. So with this you can also plot the bars with this. So here we have the bars at each points. So you can make the use of work function to get the bars. So here we are plotting only few data. That is why we have used column 150. We are selecting only 150 records for our plotting. Because when we make the use of the plot, it takes a lot of execution time. So usually it's not recommended to plot bar along with the density curve. Now, if you want to, let's plot sales density. So we can use the density function, and hist I have made false. So and another one I made hist as a true. So if you want to plot the bar, make it true, otherwise have it false. So I'm printing two plots here. So I have two plots here. In the second one, your hist is true. So that is why you can see the bars here. And in the first one, there is no bar because hist is false. So again, the thing which you can take from this plot is that lower the sale, the more is the volume of the orders, and higher the sale, the less is the volume. So let us now do the box plot that we have already done in the matplotlib. So let's make the use of C1 library to plot the box plot. So here I'm making the use of column order quantity. So here is the order quantity. Now the difference between the matplotlib and the C1 plot is that the order quantity is printed on the y-axis. So basically the values are on the x-axis. But if you remember the matplotlib where we have done the plotting for the sales data, you can see the sales value was in the y-axis. Now if you want to get in the x-axis, you can make the use of, basically you have to specify y equal to market fact order quantity. So this is on the, so your order quantity is on the y-axis. Okay, let us now do a scatter plot. In the previous example, we have made the use of scatter function in matplotlib. Now with the C1 library, we have this joint plot which is used for plotting the correlation graph between the two columns. So here we are taking an example of a sales and profit. So let us see the output. The output is almost similar that we have plotted last time. Now the addition Along with this, you can also see a bar chart here. So from this, you can say, you can conclude that if the sales are higher, your profit are also higher. But there are some few points where if the sales is higher, your profit is lower. So this is other way to plot. You can put the data frame here and the column name here. Now let us reduce some data here just to have a better understanding. Okay, I have reduced the data. So I have filtered out the market fact data where the profit is less than 10,000 and your sales is less than 20,000. So I have taken these record with this condition. So my profit and sales data is like this. So now I'm going to use some kind of argument called the hex. Using the kind argument, let us see the output here. Okay, my output is almost like a hexagon. So here you can play with the colors here if you know the color codings. I've used the blue color now. So this is the output. Let us reduce further. Now I'm selecting those data where the profit is less than 100 and sales are less than 200 just to have a better understanding. So I'm replotting with kind argument as hex and color as C. Okay, my output is now more readable here. Now here you can see that if your sales are higher, there are some point going down onward, downwards. You see the point is down, so this is a profit which is a lower one. Let us now plot another important graph which is correlation matrix plot. This can be considered as one of the most important graph because it actually gives a relationship between the various variable in a data frame, especially the numerical variable. So to plot this one, you have to put pair plot, market fact. So from the market fact data frame, it will pick up all the data which are numerical. And plot show will show the plot, and this function save fig, it will basically save the output of this plot into the core matrix file. The name of the file will be core matrix. So let's execute this one. It will take some time to execute as it finds the correlation between all the variables. Now here if you see on the x-axis I have sales. Now this is the individual graph by each column. Now also there is a relationship between each column. Like suppose here sales, and then just below sales is also sale. So basically this graph is actually a histogram plot of the sales data. Now if you see the second graph, let's come here. So I'm on second graph. So let us see what is the other variable. This discount. So this is the variable of sales and discounts. Basically from this we cannot infer anything. Let us now see the sales and profit for which we are more aware. So this is my sales. Let us find out the way the profit. So profit is here. So profit is this graph. So this is the graph between sales and profit. So if you see if the sales are higher, there are some where the profit is getting lower. Let's see the profit variable. So it's from the left to right is negative to the positive. So likewise, you can also explore some other graph. So far, we have been plotting on a single variable like a box plot, histogram, and then two variable plot like a scatter plot, which is usually used for studying the relationship between the two variables. Now, in this session, we are going to explore further, and we are going to do a plot on a aggregated value. So, for this, we are going to again use the market fact data. I'm going to re-upload all the files here, and then so I'm going to merge the market fact data and product dimension file with the joint condition of the product ID. Let us see. Okay. Now here we are going to plot a box plot of product category and sales data. So till now our box plot was based only on the one variable. So here we are making the use of two variables. We have the product category and sales data. So basically, since we are already aware that sales data is having huge variation, so we are going to make the use of log function to scale the value of sales. Let's see the output here. So here is the output. If you see, I have three box plot by each product category, and on the y-axis I have a sales data. So the way to read is, if you see the office supply, the median value is between 100 and 1000, which is around 500. And if you see the technology product category, the median value is around 1000. And then furniture, the median value is also around 1000. But the variation on the furniture is higher. Let us now plot the box plot on the profit data. And again, my x-axis is product category. Let's see the output. My output is really not readable. Since we know that the profit is also having a huge variation, so we're going to filter out some of the data. So we're going to take out those data. We are going to read only the data where the profit is less than 800 and profit is more than minus 800. So let us now make a new data frame, mark underscore plot 1. And then let's plot here with a new data frame. So this is how it is. And you can also see there are some points here which are outliers. Let's do further plotting. Now I'm going to join another data frame, which is a custom dimension, into our mark underscore plot data frame, which is also actually a join of two file, which is market fact and product dimension. So basically we are having three data frames which are merged together. Now I'm going to plot the customer segment by sales, and this is a box plot again. So here is the output. Let's do on the profit. Again, it's not readable. So again, filtering out the profit between 800 and minus 800 and making a new data frame. Then replotting it. So here is the output. So basically this is, you can practice as I'm going through here. Okay, now suppose if there are more than one category. Now in this case, I have two categories. One is the customer segment and second is the product category. So I'm going to make the use of u argument. So what we are plotting here is that we're going to plot a box plot by each customer segment and then further subdivide into the product category. Let's see the output here. So here is my output. So this picture is not readable. Let me set the figure size. For this we can make the use of figure function and then replot again. Okay. The way to read is, my profit is on the y-axis, and then corporate, home office, consumer and small business, this is the customer segment on the x-axis. And within each customer segment, we have three different product category. 1, 2, 3. So here you can see the color coding here. Office supply refers to blue, technology is orange, furniture is green. Now let us do the aggregated value plotting with the help of a bar plot. So on the x-axis is product category and I want to plot sales, and the data is from the mark plot first one. So by default, it will plot the mean value of the y column. So this is the mean value. So office supply, technology and furniture. So if you see, the furniture is having more sale, having more mean value than technology, and then followed by office supply. Since by default it is a mean value, if you want to plot with some aggregation, some other aggregator, you can make the use of estimator argument. So here I am using np.median. So I'm going to plot a median plot. So there is clearly a difference between a mean plot and a median plot. If you see, the median for the technology is higher than the mean of the technology. So it means that there is a huge variation between technology product category and between mean and median. Now suppose if you want to add another category, we can again maybe use a hue argument. So here I am setting my figure size to more larger figure size, and then my estimator is mean. So here you see my x-axis is product category, and it is further size divided into customer segment. The color coding you can read from here. Let us now do plotting based on the sum of the sales. So here you can change the estimator and rest remains same. So this is the sum of the sales. From here you can see the furniture is having the maximum sale. Let us now plot based on sub-product subcategory. The output for this graph is really not readable. If you see the x-axis, the product subcategory, you cannot read it because there are a lot of product subcategories. Now, if you reverse this one, if you make it on the y-axis and this on the x-axis, so you can read it actually. So to make this, you can simply specify the y value and x value. So initially y was here, sales here. Now x is having sales. So here is my output. Let us now do some plotting for the time series data. So for this, we are going to use the market fact data, and I'm going to combine the order dimension data frame because this data frame has got the date as one of the variable. So order date is one of the variable here, but then we have to make sure this order underscore date is actually a date column. So to do that, first let us see the description of the column. If you see my order date is an object class, is an object data type. So we have to convert into a date time column. To do that, we have to use a to underscore date time function. So it's done. So since for every date we have so many orders, so it's best to do a group by date. So to do that, we're going to use a group by function, then underscore date, and then the variable which we are going to do the aggregation in the sales column and dot sum. So this is my output. So for every date we are having a sum like 1st of January 2009, 2nd of January 2009, 3rd of January 2009. So for every date we are having sales data. Now to plot the time series, we have to use the function ts plot. So simply put the data frame here, data underscore sale that we have derived, and then let's plot. See the output. So this is how the time series data looks like. So here we can see there are some data where the sales are very high, and on the x-axis you have a date component. Now here you don't actually see the actual date here. So what we are seeing here is the number of days from the first record. Let us now explore further. So this is my current plot. Now what I want to do, I want to extract from the date, year and month, which is more user friendly and readable. So what I'm doing, I'm extracting month from the order date column by using .dt.month, and then I'm extracting year from the order date column using .dt.year. So what it will do, it will add up two new column in mark underscore ord data frame. So you can see here we have a month and a year. Now I can further group by the sales data, the mean of sales data by year and month. So let us see the output here. So here is my first 5 rows, year 2009, then I have 5 months and the sales data for each month. So now I can plot this sales data. This is the output. So this is my output. So on the x-axis, you can actually see the number of month column from starting till the end. So we have almost like 40 to 50 months. And for each month, you can see the mean sales data. Now there is another way to plot is to use a pivot table. So what I'm going to do, I'm going to subdivide the sales value under month and year like a pivot table on Excel. So we can use the pivot underscore table function that we have studied last time. So this is my data now. For each year, we have 12 months, and the data is shown by each rows under month. So now I'm going to use another plot known as the heat map. So let us see the first output. So here is my output. So the way to read the heat map is that first of all, let us understand the meaning of colors here. The higher the sale value, the darker is the color, and the lesser the sale value, the lighter is the color. Now on the x-axis, I have number of months, and on the y-axis, I have year. So let us see 2009. The highest sale was in the year, was in the month, 4th month, and the last month. For 2012, the highest sale was in the month 2, and the least sale was in the month of 8. But the common observation, if you see, the majority of higher sales are on the 12th month, is because of the Christmas holidays. So this is known as the heat map plot. So here you can also play with the colors. So you can do some research on the website to find out the color codes.